Chapter 3, Technique of Integration. So we learn how to evaluate definite and indefinite integral. We learn how to use integral to calculate the volume to find the center of mass. Well, although we know how to integrate a lot of function, there's still a lot more that we don't know how to do integration with the normal technique that we've been gone over. For example, we don't know how to integrate a function if it is the product of two other functions. So let's go over integration by part. Given h of x equal f of x times g of x, then if we take the derivative, h prime of x by the product rule equal to f prime of x times g of x plus g of x plus f of x times g prime of x. Now if we integrate both sides of the equation, then the integral of h prime of x dx is equal to the integral of the product of the derivative. Okay, so if we go ahead and solve for the integral of f of x times g prime of x, remember we can use the property of integral to rewrite the integral into the sum of two integrals, and we can solve this accordingly. So then we get the integral of f prime of x g times g of x dx equal to the integral of h prime of x minus the integral of f of x times g prime of x dx. Now remember, the integral of h prime of x is just the product function f of x times g of x. So now if we do the u substitution and let u equal to f of x and v equal g of x, then f prime of x equal to du and g prime of x equal to dv. So the integral of u dv equal the function u times v minus the integral of v du. We will use that type of we use this type of integration to solve for equations such that the integral of x times cosine of x dx. So let's start with the first example. We will go ahead and let u equal x. This means du equal to dx. We will let dv equal cosine of x dx. This means v equal to the integral of cosine of x dx equal to negative sine x. So then we will use the integration by part, and we can rewrite as that, okay, then would mean the integral of x times cosine of x dx is equal u times v equal negative x times sine of x minus the integral of v du, so minus negative sine of x du equal to dx. So this is negative x sine of x plus the integral of sine of x dx. We know the integral of sine of x dx, so negative x sine x plus cosine of x plus a constant c. Now note that when we do this type of problem, we let one part of the equation equal to u, and the other part of the equation equal to dv. So when we do this type of problem, the next thing what we do, we find du dx, right? We find du, and the next thing we find dv. So we first take derivative, and then in the second part, where there's dv, we integrate. So remember, so then we have to choose u and dv so that it will benefit us most. Okay. So how do we choose what benefits us most? So let's take a look at the next case. We'll go ahead and let u equal to ln of x plus x squared, because we know how to take derivative of ln of x plus x squared, but we don't know how to take the integral of it, right? And we'll let dv equal to dx. So then du equal to 1 divided by x plus x squared times 1 plus 2x. So simplify this, 1 plus 2x over 1 plus x squared. dv equal dx, which means v equal x. Now I can rewrite my integral of ln of x plus x squared dx is equal u times v. So x times ln of x plus x squared minus the integral of v du. So x times 1 plus 2x squared, plus 2x divided by x plus x squared So let's simplify this integral. Now we need to somehow take in the integral of 1 plus 2x over 1 plus x dx. So we do a u substitution. So I will just worry about this integral alone. So let's take this integral and we take a look at what happened to it. The integral of 1 plus 2x divided by 1 plus x dx. I can let u equal 1 plus x. This means du equal to dx. Now, note that on the numerator of the integral, I have 1 plus 2x. So I need to figure out how to represent 1 plus 2x in terms of u. Okay, I'll go ahead and solve for x in the u substitution. If u equal to 1 plus x, then x equal to 1 minus u, 2x equal 2 minus 2u, 1 plus 2x equal 1 plus 2 minus 2u. So 1 plus 2x is equal to 3 minus 2u. So now this integral becomes the integral of 3 minus 2u divided by u du. And that is the integral of 3 over u du minus the integral of 2 du. This equal to 3 ln of u minus 2u. Recall that u equal to 1 plus x. So this equal to 3 ln of 1 plus x minus 2 times 1 plus x. Well, putting this all together, the result of this integral is equal to x times ln of x plus x squared minus 3 times ln of 1 plus x minus 2 times 1 plus x. Distribute the negative over. So x times ln of x plus x squared minus 3 ln 1 plus x plus 2 times 1 plus x. So here, to solve this integral, we use integration by part and a u substitution. Okay, and in that case, the integral of x squared minus 5x times e to the x dx. So note that when we take the when we assign the u and dv, since dv we have to do the integral, right? To figure out what v is, we want to use the part where we have the least amount of work for that integral. So I will go ahead and let u equal to x squared minus 5x. And dv equal e to the x dx. Well, this is a no-brainer. V equal to e to the x, right? Because the integral of e to the x is e to the x. So then du equal to 2x minus 5 dx. Okay, let's go ahead and put the integral together. The integral of x squared minus 5x times e to the x dx equal u dv. So e to the u times v, e to the x times x squared minus 5x minus the integral of v du. So v du, that is 2x minus 5 times e to the x dx. So here I have the integral of 2x minus 5 times e to the x dx. I need to do another integration by part. I go ahead and do it again. Let u equal to 2x minus 5. Du equal 2 dx. dv equal e to the x dx. V equal to e to the x. Okay, so then this part of the integral now become the integral of 2x minus 5 e to the x dx equal u times v, so 2e to the x minus the integral, u times v, so that is 2e to the x times 2x minus 5 minus the integral of v du, that is 2e to the x dx. So then this whole integral, let's make this star, the integral star is become e to the x times x squared minus 5x minus e to the x times 2x minus 5 plus the integral of 2e to the x. So here we have e to the x times x squared minus 5x minus e to the x times 2x minus 5 plus 2e to the x plus c. Let's talk about in general when we want to take the integral, the cosine of x to the exponent n times d of x. Okay, so we'll go ahead and we will let u equal cosine exponent n minus 1 times x, and let dv be cosine of x dx. So then du equal n minus 1 times sine of x dx times sine of x times negative sine of x times cosine to the exponent n minus 2 of x dx. So let's clean this up a little bit. Negative cosine, negative n minus 1 times cosine to the n minus 2 of x times sine of x dx. Since dv equal cosine of x dx, v is equal to sine of x. So then the integral cosine to the n of x dx is equal u times v. So that will be sine of x times cosine to the n minus 1 of x minus the integral of v du. Integral of v du equal to, and we have a negative 1 out front, so we make this positive, so that is n minus 1 times sine squared of x cosine of n minus to the n minus 2 of x dx. Okay. Now I can go ahead and rewrite this as the integral of cosine to the n minus 1 of x times sine of x plus the integral. We'll factor out the n minus 1 out front. Sine squared of x is 1 minus cosine squared of x times cosine to the n minus 2 of x dx. So let's go ahead and distribute the cosine to the cosine exponent n minus 2x over. So we get cosine to the n minus x times sine of x plus n minus 1 times the integral of cosine to the n minus 2 of x dx minus n minus 1 the integral of cosine to the n of x dx. So I'll just go ahead and bring the cosine, the integral of cosine of n of x dx down. So note that here I have a like term of sort. Okay. I will go ahead and we add the term n minus 1 integral of cosine of n to the x to both sides. This now becomes n times the integral of cosine to the n d of x equal cosine to the n minus 1 of x times sine of x plus n plus 1 times the integral of cosine to the n minus 2 of x dx. We can divide n by the both sides, so then the integral of cosine of n to the x dx equal 1 over n times cosine of n minus 1 times x sine of x plus n plus 1, n minus 1. Cosine to the exponent n minus 2 of x dx, and we have that integral. Okay. So let's go ahead and see how do we apply this to a word problem. We want to find the area of the region bounded above by the graph of y equal tangent inverse of x, below by the x-axis over the interval 0, 1. Which means we want to make the integral from 0 to 1 of tangent inverse of x dx. I will go ahead and let u equal tangent inverse of x. So du is equal to 1 over 1 plus x squared dx, and I let dv equal to dx. So u equal to x. Then this integral become u times v, so that is x tangent inverse of x. Evaluate from 0 to 1 minus the integral from 0 to 1 of v du, that is x divided by 1 plus x squared dx. I can solve this integral using substitution. I will let u equal 1 plus x squared. So then du equal to 2x dx. So 1/2 du equal equal x dx. I will then change the upper and lower limit. When x equals 0, u equal 1. When x equal 1, u equal 2. So this whole integral star become x times tangent inverse of x. Evaluate from 0 to 1 minus the integral from 1 to 2 of 1/2 du divided by u. Evaluate this whole thing, we get pi over 4 minus 1/2 times ln of 2.